Good morning, everybody. Hopefully you're ready for another exciting morning of chemistry with Dr. White. Oh, by the way, I love your costumes. You all look like chemistry students. So, I have brought good stuff. Take one and pass it around. I have another bag so we can do a second round. If you don't want it, pass it on. All right, there's some things I'd like to review because coming up a week from today will be test number 3. Test number 3 will cover gases and solutions chapters. Sometime tomorrow I'll post that on Blackboard and I'll also send out an email. But there's some important things I'd like to cover today to help you prepare for test 3. If you notice, I have the anybody see the eraser hiding around here somewhere? I do not see the eraser. I'll be right back. I'm going to have to go steal an eraser from somewhere. Unless it's under, nope. Hold on. Good news, I have an eraser. All right, Bobby, you want to send that back around the other way? Take a second one. I got another bag just in case we run out in that one. All right, now I'm ready to go. All right, you should know, and this will be an important information, but I'm going to write it down. When it comes to gases, torr or millimeters of mercury equal 760 torr equal 1 atmosphere. This will be given to you. And therefore, you should know how to do why don't you try this one first, and then I'll do it. And the question is, all right, hold on, oh, wrong bag. Right there. Start around again, and keep on passing until that bag's gone. Now you're all on a good sugar high. You're in the mood to do this problem. How many atmospheres is 856.1 torr? Then I'll do it. Take one and pass it back around again. Remember, take one. It looks better on you than me. So some of you like that truism. See, Dr. White wants to do this. Remember, it's a long class. Anybody wants extra before you leave, here's some. All right, let's take a look at it. I'll give you another 30.6 seconds. Go. All right, let's do this. All right, what are we being asked to find? How many atmospheres? What are we given? This number. And if I can convert from this to this in one step, how do I do that? Well, this is the only number I have. I want to get to atmospheres. Now, what do you use? Oh, I have to start out the morning fresh. Use your good buddy, your good friend. Stop. Don't forget to take one or take two.
Okay, thank you.
Or don't. It's a free country, still. All right, use unit analysis. Whatever you're trying to get to goes on top. Whatever you're trying to get rid of goes underneath. Where do I get these numbers? From this. You know that 760 millimeters of mercury equals 760 torr equal 1 atmosphere. I can put this in here. My units cancel out. These are exact numbers because this is a definition. Therefore, I can go to my calculator, pull down the screen. And and this is the number my calculator gives me. Let's take a look at this. This is 4 significant figures. These are exact numbers. Round that off to 4 significant figures. I'll give you 3.8 seconds. 3.2, 3.6. Time's up. We keep the 1, we keep the 1, we keep the 2. 6 is number 4, therefore I use the 4 to round off. Is that 4 or less? Yes, it is. So the correct answer here would be 1.126 atmospheres. Speaking about correct answers, one of your colleagues emailed me yesterday with some mistakes I made on the solutions problem set. I should have those corrected by Friday. And I appreciate the colleague who found mistakes. I don't appreciate me making mistakes, but that's life. All right, let's move on to important things you should know and know how to do. For gases, you don't use Celsius or centigrade, you use Kelvin. And you'll be given this formula. Kelvin equals degrees C plus 273. And therefore, Then why don't you try this one? What is the temperature of a gas in Kelvin if the temperature is 121 degrees C? By the way, in case you don't know, chocolate is a chemical, so you're doing chemistry if you're eating the candy bars. All right, looks like everybody's done. So what are we being asked to find? We're being asked to find Kelvin. What are we given? On test 3, this will be an important information. So in keeping with my new philosophy, teaching chemistry, I started last spring. I'm testing you for your knowledge of chemistry, not your ability to memorize. And therefore, you should know that Kelvin equals degrees C plus 273. For this one, it's 121 plus 273. Let me get my calculator out. Hopefully I did the math. Remember addition, you have the same number of significant figures past the decimal as the number with the fewest past the decimal. This is the only number, 0 past the decimal, 0 past exact number. All right. Everybody have this written down? Do you want to write something down? Going once, twice, gone. Next thing I'd like to cover that you should know how to do is Boyle's law. And that's P1 times V1 equals P2 times V2. And just in case you forgot, P1 is the initial pressure of a gas, and this is dealing with gases. That's why it's called the gas law. And V1 is initial volume. P2 is the final pressure, and V2 is the final volume. This will be given to you important information on test 3, but you still have to know how to use this. And let me give you one to try, and then I'll do it. If a piston, and that's like in your car, your piston, has a pressure of 621 torr at a volume of 24.1 liters, then what happens to the pressure if you change the volume to 2.411. Enjoy. And again, thank you for coming out on such a miserable day. Oh, I forgot something here. Is that better? It's monitor turned away. Is that better? By the way, if you can't see, you can come up to the board and look. Or ask me which part you can't see. All right, let's do this. And if you look at this, what are you dealing with? Only pressure and volume and a gas. As soon as you see that, you should know PV equals PV, P1, V1, I got ahead of myself, equals P2, V2. I'll do this again. P1, V1 equals P2, V2. How do I know that? First of all, what are you being asked to find? A final pressure. What are you given? The initial pressure equals 621 torr. The initial volume is 24.1 liters. And the final volume, V2, final volume, is 2.411 liters. And now, what are we trying to solve for? P2. Notice the only variables you're dealing with are pressure, volume, which means we use this. What are we trying to solve for? P2, we want a load on one side. How do I get rid of something when you're multiplying? You divide by that. Whatever you do to one side, you have to do to the other. This cancels out. Anything divided by itself becomes the number 1. And therefore, we have P2 equals P1 times V1 over V2. Dr. White's going to rewrite it. You don't have to. And since I took the time to figure this out, it's easy to put in what is P1, what's V1, what's V2, and now before I pick up my calculator, I'm going to use my good buddy unit analysis again and see, do the units cancel out so I get the correct units? Because if they don't, you've done something wrong. Notice liters divided by liters, same unit, becomes 1, gone. I'm left with torr, which is a measure of pressure, so I'm on the right path to success. And now I'll come over to my calculator. And the number I get is this humongous number. And what do? Well, let's look at it. On test 3, like test 1 and 2, we'll say please use proper significant figures for all calculated answers. And if you notice, this is 3 significant, 3, 4. When you're doing multiplication division, the number with the fewest significant figures is the same number your answer should be. So how do I round that off to 3? I have 6, keep the 2, keep the 0. Use the 7 to round off, that's 7 or greater. I'll drop that, replace it with 0, increase that to 1, and therefore, or if you have your calculator set up for scientific notation, which I will now do, I get this number, and same thing, it would be equal to 6.21 times 10 to the third, which is this, and therefore both have 3 significant figures, because a 0 at the end without a decimal is not significant. Either answer would be correct on a test of mine. Did I tell you I'm this close to the person who grades the test? Me? Here, question.
So if your calculator is on scientific notation, that means we have to write the times.
No, you can do either way.
But if we just write the 6.21, is the
Well, you got to put times 10 to the third.
That's what I'm trying to say.
Yeah, you
So,
have to, otherwise it's wrong.
okay.
That's part of scientific notation. 6.21 is the number between 0 and 10. 6.21 times 10 to the third is a number between 1,000 and 10,000. Big difference there.
Okay.
Especially if I were to ask you, which would you rather have someone give you? $6.21 or 6.21 times 10 to the third dollars? I'll take the second one. But that's a good question, and now you know you won't make that mistake on the test, which is a good thing. All right. Any questions, other questions? Remember in my class, all questions are good questions. All right, let's move on. Things you should know. But first, a commercial from Chem 1105 YouTube channel. By Saturday morning, probably earlier, today's lecture will be on the YouTube channel. There's a link in Blackboard in case you don't know. All right. And Dalton's law of partial pressures, which you'll be given, the total pressure of a mixture of gases is the sum of the partial pressures of each gas, P1, P2. Partial pressure, which I'll never ask on a test, but that's the pressure of a gas if it were alone instead of in the mixture. That's what the pressure would be of that gas. So, this is Dalton's law of partial pressures. And let's take a look at the following question. And the question is, a mixture of oxygen, O2, and carbon dioxide has a total pressure of 751 torr. And the carbon dioxide partial pressure is 111 torr. What is the partial pressure of oxygen? Have fun. Again, I'd like to thank you all coming out on a real beautiful morning. Not. And as I said when I first started the class, who's ever dreaming of a white Christmas, stop. Wait until at least after Thanksgiving. It's coming up too. Only one more shopping day till Halloween though. All right, I think everybody's done. Let's do this. What are you being asked to find? You're being asked to find the partial pressure of oxygen. What are you given? The total pressure of this mixture of gases is 751. Hold on one second. New markers are very slippery. You're also given the partial pressure of carbon dioxide, which is the other component of this mixture, is 111 torr. And notice you're just dealing with pressures of a mixture. Immediately, Dalton's law of partial pressures, P total in this case, equal the sum of the partial pressures of this gas. In this case, it's partial pressure oxygen, partial pressure carbon dioxide. What do I want to solve for? Partial pressure oxygen. When you're doing addition, how do you get rid of something? You subtract it. Because anything subtracted from itself becomes the number 0, it's gone. So if I want to solve for partial pressure oxygen, what I have to do is this. Whatever I do to one side, I have to do to the other. This to subtract from itself becomes the number 0 plus partial pressure of oxygen, say that 5 times quickly, is PO2. This is still P total minus PCO2. I'm going to rewrite this because I like to do that. Everybody with me so far? And now I took the time to figure out the numbers so I can pop them in. And if I do the math correctly, and check me if I'm wrong, that's the number you get. Now remember, addition, subtraction, you get the same number of significant figures past the decimal as the number that has the fewest significant figures past the decimal. This has 0, this has 0, this has 0. Even though you say, well, I started with 3, how can I end up with 2? You don't consider that for addition, subtraction. It's just what's past the decimal. Any questions on this? Moving along, let's go to the next one that you should know how to do. And that is my favorite mathematical formula in chemistry, PV equal nRT, the ideal gas law. PV equal nRT, what is P? P is pressure, and it's always in atmospheres. V is volume in liters. N equals moles, you know what that is. R is the universal gas law constant, and for this class we'll use this value, which is 3 significant figures. It's not an exact number. And here are the units, atmospheres, liters per mole, okay? And finally, T is temperature. In Kelvin, and because of that, I'll remind you, and this will all be on important information for test 3, but you still have to know how to use it. Balloon, 1 L or 2 L's, or did I spell it right? Look out, I'm on a winning streak. Write that down on your Facebook page. Dr. White spelled balloon right today. And the question is, what's the volume of a balloon that contains 26.7 grams of ammonia at 101 degrees C and 26.7 liters? And 15 points. Why don't you try this, and then I'll do it. I'm going to take a walk around the block and come back. If you don't have a calculator, just try and set up the numbers. What you're trying to calculate, find, and be with you in a second here. And then, how do you do that? Did I write something wrong up there? Hold on, let me see. Volume. Ah, I see what I did wrong. It's the snow, throws my mind off. Now I got it right. Thank you all for giving me that. What are you doing today, look? Must be the candy bars you all had. You don't get off my cane. Is that your question, Vera and Celestina? Thank you. And look out, Bob, you have no names now. difficult. Or look up and smile. Let's see if you guys see. Okay. Guess you don't know what that means. Someone close the door back there. If I can hear it, you all can hear it. Thank you, Daryl. All right, looks like just about everybody's done. Let's go ahead and do this now. If you're not, just pay attention. You'll have time to do it on your own. You can take it home and work on it. Just cover the answer and try it on your own. And let's go ahead and look at this. What are we being asked to find? We have a gas, and we're asked to find the volume. What are we given? We have 26.7 grams, and we're given what's the identity of that gas, ammonia. We're given the temperature. We're also given the pressure. And as soon as I see a gas problem with only volume, weight, temperature, pressure, and nothing is changing, immediately I know I'm dealing with PV equal RT. And what are we being asked to find? Volume. How do I solve for volume? I get it alone on one side. In this case, how do I get V alone? Divide by P. Because anything divided by itself becomes the number one. Whatever I do to one side, I have to do to the other. Now, anything divided by itself becomes the number one, times V times one is V, volume, and now nRT P. But wait, I now have to do the important thing. Remember, P has to be in atmospheres. It's not volume. Well, I'm solving for that. Moles, wait a second. Where do I get moles? Well, it will be given to you on test 3. And 1 mole of a compound equals molecular weight. And molecular weight is the sum of all its atomic weights. Therefore, I can change weight into moles. And therefore, let's get started. First of all, N equals, well, I have a weight, 26.7 grams of ammonia. I want to get to moles of ammonia. You see that now? It's there. Anyways, I'll use unit analysis. Whatever I'm trying to get to goes on top of the ratio. Whatever I'm trying to get rid of goes underneath. Where do I get those numbers? Oops. 1 mole equals the molecular weight of a compound. If this is 1 mole, the number that goes there is the molecular weight, which is the sum of all atomic weights. I didn't give you nitrogen, sorry about that. You will be given a periodic table. And we've done this before in class, but 1 nitrogen, 1 times 14. This is a G here, hold on. There. And add it up, 1 past the decimal 2. How do we round this off? This becomes 17.0. I'll now come over to my calculator. And this is the number I get, 1.570588. You can round off at the end or each step. I'm an each step person, 3 significant figures, 1, 3 significant figures. 1 is an exact number, therefore the answer would be here, 1.57. So I have 1.57 moles. Next, I'll go over and say, what's next here? Temperature. Temperature equals degrees C plus 273. What do I have? 101 degrees C plus 273, and that equals 374 K. I've got temperature done. What do I have left to do? Pressure. Pressure should be in atmospheres. And I have 749 torr. And as we did earlier today, what are we trying to convert it into? If you come over here, you're told pressure should be in atmospheres. And what do? Use unit analysis. What I'm trying to get to goes over there. What I'm trying to get rid of, well, first of all, what I'm trying to get to goes on top. What I'm trying to get rid of goes underneath this ratio. I don't have it here, but I gave it to you earlier. 1 atmosphere equals 760 torr. That will be important information. This is 3 exact number. Dr. Whiteson is right again. Let's see, this was 374. And this is if I round that off to 3 significant figures, I will get 9.86 E minus 1. Whoa. And now I'm ready to put things in. And since I took the time to write this out this way, I can do N, 1.57 moles. I'm going to erase this to give myself some more room. N is still 1.57 moles of ammonia. R is the universal gas law constant. Give myself a little more room, and I wish we had bigger boards in this room. And K, temperature, is 374 K. Then I'll divide it by my pressure, which I have as 9.86 times 10 to the minus 1 atmospheres. Now, before I go any further, I'm going to check my units. I'm going to cover this part and say what's underneath atmospheres, what's on top atmospheres. That cancels out. Oops, wrong thing, cancels out. This cancels out. Then I'll cover this for the time being and say moles divided by moles cancels out. K divided by K cancels out. What am I left with? L, that's volume. That's what I'm trying to find. I'm on the right track. And now let's do the math. And notice, it happened, wow, this is a weird semester. A lot of this is happening. It happens, and that's also why I'm confident I like to do it at each step works. And if you notice, I'm back in my rut again. 3 significant figures. This is not an exact number. It's 3 significant, 3. Answer should be 3. What do we round that off? Either way, you get 48.9 liters. And that's how you do this. Now, interesting thing, well, not interesting, but nice thing happened last night. My best friend who lives in Fort Wayne, Indiana, called me, and I've known Neil since, oh, I hate to say this, sophomore year of high school. Boy, should I say it? I'll say this. Everybody groaned after I say this. That was back in, I think, 1965, so we've been friends that long. He's my best friend. And luckily, I'm also very good friends with his wife, who he married in 1978, and which is also nice. She's the best friend of mine for a long time. And he was saying, you know, it's going to get cold out, and you know when it gets cold in the winter, my car tire sensors tell me to check the pressure. And you know why? Because the temperature goes down. I said, Neil, you know who you're talking to? Someone who knows PV equal nRT. When the temperature goes down, the ideal gas law tells you, check your car tire pressure, because the pressure is going to go down. Same thing in the summer, when the temperature goes up, your pressure goes up. And he said, oh, come on, I forgot. I've taught him some chemistry. By the way, he's an acoustical engineer, actually a design engineer by training, but one of the best electronics people I've ever met in my life. And he and I have been doing electronics since high school, but he really knows it better than I do. And some of the speakers in your car, he designed when he was at Motorola, and other things. But anyways, he's always forgetting, don't teach me chemistry, because I know it better than him. But anyways, PV equal nRT. Let's move on. We've got enough time to cover a couple more important aspects. Talked about solutions. Solutions, you should know the solvent is the component of a solution that's present in the greatest amount. The solutes are the other components of the solution. Anybody think of, right now you're sitting in a solution, air, and the solvent is nitrogen, because that's the component present in the greatest. Now, one of the things I talked to you about, concentration, that's very important, is molarity. Spell it. And that's equal to moles of solute times divided by 1,000 milliliters. This will be given to you. Now, before I go through this one, there's something important I need to discuss. And the question is, what does this mean? And as soon as you see the capital M, you should remember, capital M is used for molarity, moles solute per 1,000 milliliters, and this means 3.11 moles sodium fluoride per 1,000 milliliters. And with that, let's go over to the problem. I'll let you try. How many moles? Oh, did I hit the floor? Well, it didn't explode. Anyway, how many moles of HBr are in 95.6 milliliters of 11.5 capital M HBr solution? HBr is hydrobromic acid. Remember, today's video will be on channel CHEMI 1105 on YouTube. And you'll see your favorite YouTube star, me. Oh, maybe not your favorite. I've never looked to see if they have any Jimi Hendrix live on there. I saw him live in high school. But you can see me on YouTube. Courtesy of College YouTube page, because they lent me that equipment. I'll give you 5.2 seconds. Uh-oh, I'm stuck on 3. Oh, 4. 5, 5.1, 5.12, 5.1. All right, let's do this. What are we being asked to find? How many moles of HBr? What are we given? Well, we're given a volume of a solution, and we're given this number, 11.5 capital M HBr. And as soon as I see the capital M, I ask myself the question, what does that mean? And I know that means molarity, moles solute per 1,000 milliliters. Immediately I can put 11.5 moles HBr per 1,000 milliliters. Now, the only thing I really have to start with is this, so I will. And now I'll use unit analysis, and what do? Whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of goes underneath. Where do I get those numbers? From the molarity, which I know means moles per 1,000 milliliters. In this case, 11.5 moles of HBr per 1,000 milliliters. My units cancel out. Milliliters divided by a milliliter becomes number 1. It's fine. And this is 3 significant. This is 3. This is a number that's in the definition. Therefore, it's an exact number. And now I'll go to my calculator. And the number I get, rounded off to 3 significant figures. By the way, 10 to the 0 power is 1, in case you didn't know that. But if you want to put down 10 to the 0 on the test, that's okay. This rounds off to 1.10. I think I had that come up the other day. Wow, that's spooky. Halloween's coming up. Spooky. That was lame. Remind me, never do that again. All right, let's move on, because I'm running out of time. Because as you know, I never go late over a lot of time. And the next thing is how many grams HCl are needed today, 562 milliliters of a 2.34 capital M HCl solution. And because we're running out of time, I'm going to do this, but you can go back and cover this and try it on your own at home. I won't stop you from doing that. And first of all, what are we being asked to find? Grams of HCl. What are we given? 562 milliliters and 2.34 capital M HCl. As soon as I see capital M, I know it's molarity. Molarity is moles of solute, 2.34 moles of HCl per 1,000 milliliters. On test number 3, and important information, you'll find out this is a 2-step problem. And this you'll be given. Step 1, we go from milliliters to moles. Step 2, moles to grams. And if I look at this, well, I only have this number in milliliters, so that's simple. When I do step 1, I'll have 562 milliliters. I want to get the moles of what? Well, I'm trying to get the grams, so first I'll go to moles of HCl, and now I'll use my good friend, my good buddy, unit analysis. I have to slip that in one more time. And whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of goes underneath. Where do I get moles per milliliter? From the molarity. And the molarity is 2.34 per moles of HCl per 1,000 milliliters. And now if I look at that, I'll see that my units cancel out. And I'm left with the right units. So now I'll go up to my calculator. And this is the number I get. And at this point, I'm going to round it off. You can do either way. I accept either way. Those should be 3 significant figures. And that's 1.32 moles. Am I done? The answer is no. How do I know that? Because I'm trying to get to grams of HCl. And right now I have moles. So now I'll do step number 2. Which someone was nice enough to write on the board is go from moles to grams, which you learn for test 2. Ooh, a lot of 2's here. And we have 1.32, ooh, another 2, moles of HCl. I want to get to grams of HCl. I'll use unit analysis. Whatever I'm trying to get to, I'll put on top the units, grams of HCl. Whatever I'm trying to get rid of, I'll put underneath, that's unit analysis again, moles of HCl. And where do I get that number? On test 3, it will say 1 mole of a compound equals its molecular weight. And the molecular weight, you'll have a periodic table. Hydrogen is equal to 1.01. Chlorine is equal to 35.5. I use these numbers a lot, so I know them by heart. You don't have to. This is 36.51. 1 past the decimal, 2, drop that. This is 36.5. And I put that in there, come back to my calculator. And finally, we got a difference, slight difference, but if we look at this, if you round it off at the end, you'll get 4.82 times 10 to the 1 power. If you wait and if you do it at each step, you get 4.80 times 10 to the 1 power, which is the right one, either one. How did I do on time? Wow, am I good or am I good? Even with our delays, this notice one. All right, listen up.